Okay, good afternoon. Okay. Well, I guess I still have 2 minutes, at least. Does anyone, you probably all have it memorized. What's the last day of classes?
May 7th.
Yeah, that's what I thought. It still seems kind of far away. Why? I thought it was the 8th, but whatever, the 7th for this class. I guess it is less than a month, but just barely.
Yeah, I guess for this class it'd be the 6th.
Okay. Yeah. One, two, three, 4, 5, 6, 7. We still have 7 classes. All right, that's good. I mean, we're going to get done with some good stuff. For those of you that have some kind of picture of yourself up, thank you. It really makes a little bit of a difference. It's better if you had your videos on, then I could actually see you. I was telling someone the other day about how this goes, and they were like, "What? You can't see them?" I'm like, "No." Oh, there's Kyle. So maybe we should start by seeing if anyone has questions about the homework. Did I hear anything? No. How many people have done it? Raise your hand if you've done it. Kyle's done it. Tim, Zach. Where is okay. So just a few of you have actually done it. I made it due later, but gosh, I thought some of you. Well, so I don't know. Maybe you don't have a picture of yourself.
Yeah. Okay.
Hi, Tim.
Put a
Thanks.
picture on.
Just to see a few of you. All right, so I guess I kind of like, since we're down to like a relatively small group that continues to attend, I mean, it's like half the original class size, but I guess I post the videos, and so some people just figure they don't need to attend. So I don't know how many are here. Not that many. 19. You know, less than half the original. So anyway, maybe I don't know. Can you tell me how it's going? How this class is going? What if I go around, ask you? All right, Kyle first. Thank you.
The written notes are a little hard to follow.
Are they? My
Yeah.
handwriting's hard to
Yeah,
read.
just the handwriting is hard. It's hard to read sometimes.
Sorry about that. Yeah.
But yeah, other than that, yeah.
Tim, what do you think?
It's a lot of really hard thinking, and then once it clicks, it becomes really easy.
Isn't that interesting? Yeah, I think that's true in some way. Once you like see it, you go like, oh, of course, that's what you have to do. But to get there, like, I don't know. I mean, a lot of times, David Grease was one of the like, he was friends with Dijkstra and one of the grandfathers of programming. And he was at Cornell. He was kind of a famous software engineer, programming guy. He used to say, oh, students guess their programs. And it's actually not that uncommon for, once you don't get it, you start just randomly typing in anything that looks like it might work without understanding. Now, I see Tim being skeptical of that, but you know, some people don't. Some people think hard and write it down right. You know, I've got one graduate student working with me now that is really good at that. You know, he stops and thinks. Parker, what do you think? What's the story with the class for you?
I'm still waiting for things to click, I guess. I don't know.
Well, maybe you ought to come to office hours and we could talk. Or, you know, I don't know, right now, maybe you could tell me what's the hardest, you know, what do you feel like hasn't clicked? Are you having trouble reading the notation in the book, or are you having trouble writing the Haskell, or both, maybe?
So it's like I can read along in the book, and I don't have any questions. It's not like, you know, I'm like, I read it and I'm like, that sounds correct, but I don't know. I don't understand it enough to like, you know, do it myself, I guess. And then I think I really need to work on functional programming. It just, I don't know. I am so like not comfortable. But so I don't know.
Okay, that's good. I mean,
Like,
maybe I'm gonna try and address that today a little bit, because I'm thinking of doing the opposite of what we've been doing. So far, what we've been doing is taking the formal notation and turning it into Haskell. And today I'm thinking of taking Haskell and writing it down as the formal notation so that you can see how it goes backwards. Zach, what do you think?
I think everything's going pretty good.
Yeah. Okay. Jessa.
Hi. Yeah, it's good. I've just been following the book, so it's fine. The programming assignments are a little confusing sometimes, but they're good.
So it's more Haskell for you than the technical notation in the book.
Yeah, I think so. I think
that, yeah, that's a problem I think a lot of people have.
Yeah, I think it would be kind of nice to have homework assignments that are, I guess, just based on the material, maybe like less coding, just like a few, just kind of the foundations, but that's fine. Thank you.
Okay. Andy, what do you think?
Yeah, no, I definitely agree with a lot of that, because personally for myself, I'm kind of 50-50, whereas like I can go through and I can read the book and I can understand the formal notations and stuff like that. But when it comes to Haskell and that functional style of programming, that is kind of where I start losing my grip on what's going on and what's happening.
Did you take 3015?
Yes, I did.
Last semester? Or before that?
Yes. Yeah, I believe so.
Okay. Isaiah, what do you think?
I think it's all kind of hard. The Haskell's kind of tricky, just like understand how that goes, and then the notation in the book is hard for me to track. Like I'll track it one day and like kind of start to go piece by piece, and then I look at it the next day and I'm lost again. But yeah, I'm surviving.
How about you, Yikai?
I agree with all those. Like I can read a book and look at the rules and it all makes sense, but translating the rules to Haskell, it's just kind of tricky.
Okay. Tatum.
I agree what everyone else has said. It's helpful to be able to come to class and then rewatch the lectures a couple times to hopefully make it stick as well.
Okay, so the recorded lectures are useful. Well, that's good to know. Addison.
I mean, I don't know if anybody else feels this, but for me, with this material, I just feel like there's a lot of time where I can like spend hours just trying to like parse my way through the rules in my head before I get like an aha moment. Suddenly clicks, and then I feel like I can start replicating it in Haskell a little bit, but sometimes it just takes me a long time to really get my head to that point where I can wrap myself around and like understand the notation. It's a little abstract, so it just takes me a while to get it, but usually there's a moment. Sometimes it can take a few days for a given topic, but it just takes me a long time to get that moment where I wrap my head around it and I can like replicate it in something else.
Well, it's not surprising. I mean, I think in a way, like, I hope everyone's taken 3015. It's a prereq. But you get the flavor of Haskell in 3015. You don't really learn how to program. And for some people, I'd say about 10%, it just clicks and they go like, oh my God, this is the only way I ever want to program. And then for most people, though, it's like, you make it through, but it doesn't feel like you really got the language. And then we're also learning kind of like this new formal language of rule notation. So you're kind of trying to learn two languages at the same time here. Josephine, Kay, Josephine, Hennig. What do you call yourself? Do you call yourself Josephine?
Yeah, I go by Josephine. It's okay. I feel like I'm struggling understanding the material in the book. And then the homework sometimes are just confusing to get started, but once I understand, then it doesn't seem too bad.
Okay. afooley12@uwyo.edu.
Oh yeah. I only have that because like that's the only place I have my image saved. So you can see my face. But so I feel like the homework is confusing a lot of the time. And maybe it's just not understanding it well enough. But yeah, it seems like the homework is the sticking point for me.
Okay. Brandon, did I hit you yet? No.
So I guess for me, like for the most part, I feel like I understand most things. However, there are like maybe a few concepts when I'm reading through that I end up kind of confusing myself on it. And then when I hear it explained, then I am normally able to work through it.
Okay. That sounds kind of like most courses then. Hopefully you're like, have to work at it to get the material. Tanner, what do you think?
So I agree that sometimes it can be hard to put the rules like into Haskell code and stuff, but I would prefer less coding homework because I at least personally, I feel that it's more beneficial to do like real kind of examples. And the notes, the notes are a little hard to read.
Okay.
But otherwise, I'm enjoying the class so far.
Okay, great. Okay, let's see. Jack McDonald.
Yeah, I mean, I'm going to sound like a broken record, but yeah, I agree with what everyone else has said. The Haskell is where I definitely struggle the most, so I definitely need to practice that. But other than that, it's going well.
Okay. Asher Summers. Can't hear you for some reason. I think your microphone is on, but can anyone hear? No.
Yeah, I can't hear.
No.
Okay, you're having some kind of microphone problems. Okay. John Desinfants. I'll come back to Asher in a few minutes.
Yeah, just kind of the same as everyone else, just still not that familiar with functional programming and Haskell in general. And then sometimes the concepts are hit or miss for me, although I'm gonna have to be honest, part of it is probably just my own time management ability or more lack thereof.
Yeah, well, I think that's for all of us in a way. I'm terrible at it.
I feel like these should be easier than I anticipate, and so I put it off, and then I'm suddenly scrambling to figure it out.
Yeah. Asher, do you think your microphone's working?
Hello, can you hear me now?
Oh, now we got you. Yeah.
Sweet. Yeah, I find functional kind of counterintuitive at times. Like, I usually need to think about it a lot more than I do like object-oriented languages, just because I guess I'm not really used to it that much. But I do feel like the homeworks have been kind of helping with that so far.
Okay. Letitia.
Yeah, kind of same as everyone else. I've been kind of like, sometimes I've been struggling with the homework. Sometimes I get it, but then sometimes, like the last one, I just like, I can't figure out how to do it. Like I looked at the stuff in the book, and like it says like it says that this thing is this way, and then I'm like, okay, I'll try to put that into the code, and then it doesn't work and doesn't even do what I thought it would make it do. And it's like I can't figure out how to translate between the notation in the book and the code because it like doesn't make sense. Like, for example, for the last homework, like which like putting the store next to the environment and like where exactly that's supposed to be, if that's even how to do it. I think in that case the environment being like 1 instead of 2 also made it more confusing, harder to translate when there's that many differences.
Yeah, I guess. And then my moving next, although I noticed I was reading ahead to like refresh my memory. And like if we go on to the records next, the structured declarations, there he moves the next pointer out of the environment and into the store. Like, I don't know, he realized it late, but I think that difference does make, and then the fact that we have one environment instead of 2, maybe, you know, but that's a kind of like a refactoring that would be that you would commonly see. Like instead of passing 2 things around, you put them in a package and pass 1. But yeah.
Yeah, but it just still makes it more difficult to tell what goes where and which thing is which version of the thing and what each part of the code is doing. Like mapping the code to the notation is that's what's really difficult for me. Can't figure out how to translate it over.
I think maybe one thing that might have helped is if I wrote down the rules for our version instead of saying, oh, read these rules and, oh, ignore the next pointer. And, you know, instead of doing it like that, I probably should have like written down the rules for that match the code. But that's what we're going to do today. We're going to work backwards a little bit. Soren.
So I am having very difficult time in programming in Haskell. And also the notations in the book looks very difficult to understand. So even if I have the concept about those homeworks, but it's sometimes difficult, not sometimes, like most of the times it is difficult to interpret in Haskell code.
You didn't take functional programming, did you?
No.
Yeah, so that makes it really hard.
Yeah.
Okay. Hannah.
I kind of agree with everyone else. I think programming in Haskell is sometimes difficult, and also just for me personally, sometimes it's hard to like grasp all the different concepts that we're going over. But if I also put some extra time into it, I'm sure it would be somewhat easier probably.
Okay. All right. Well, I don't know. We spent, I don't know, what did we spend? 20 minutes doing that, but I think it's going to help me maybe moving forward. And it feels good to hear everyone's voice just for once. So I don't know. It does. I know how that feels. Like, okay, we're going around in a circle and tell us who you are and how you feel. I mean, I don't know. Then you sit there waiting for when you're going to be called, and it's not that much fun. But thank you for putting up with that. I mean, you can always just like sign out. Anyway, please don't. Please don't. I'm not saying sign out. All right. So I thought that, and I guess I'm not sure. What's the best way to do this? I want to, I don't know. I spent my weekend working on this code too, because I was like, oh, I want to make it better. Like there's a few parts that are that I thought were kind of ugly. And so what were they? Let me see if I can get this going. You know, I discovered something. Oh, first I have to share screen. Why does it say I've got a JavaScript error in the main process? All right. Okay. No. Okay. This is, I don't have access. This is frustrating because I finally discovered exactly what I wanted. Okay. I have OneNote that runs on Ubuntu, except that today it seems to be having trouble. I have not had any trouble with it so far. What a pain in the neck. All right, and then we can go and look at Emacs. And so what I want to do is I want to like work backwards from I've kind of modified the declarations in this new version of the code. So the thing is that, well, let me get here and make a new, let's see, cosine 4780, and then let me make a new page here.
I'm sorry, can I ask a quick question about the
Sure.
assignment?
About the what?
The assignment?
Yeah.
I'm sorry about this. What
No.
file are we editing? And then which one are we submitting? Is it the bumps.hs file?
Yeah.
Okay, cool. Thank you.
Bumps.hs, and then your evaluation of the various programs.
Okay, thank you. Sorry about that.
Yeah, the output, the testing, you know, there's that code there. There's a file there called bumps, I think, underscore expected.txt. And if you look at that, that shows you what the commands you're supposed to, you know, which files you're supposed to test.
Okay, thank you.
All right, let's see. How do I add a new? That is so weird. What's going on here? I wonder if I shut it down and restart it. Of course, I may not get it back at all. It seems to be sort of working. Okay, so we're going to try and go backwards, go from the code to the rules. So, come on, baby. Now I got to get my iPad going. And get to the same page. Where's it? Going backwards. Okay. Okay. So, you know, notice that. Let's see. I gotta check. Select a. Okay. Notice that semicolon in the language, in the statement language, has a semantic, is assigned, is an operator. Let's see, why am I going over it? Okay. And we see that over here in the code where for statement, this seek thing is seek statement is, you know, we've got seek is a constructor for statements, which, you know, which gives a sequencing operator. And so if we go down and we look at the code for big step semantics for example, seek. So here's the code. I wonder if there's any way, is this going to work? Can I like copy that and paste it in over here? That would be interesting. Okay, not very big, but maybe I can make it bigger. So anyway, there's the code for, I'll try to fix this up a little bit after the class. Can you read that code? You can read that, right? It's not scaling though, is it? So anyway, so how do you translate this kind of thing into a rule? Well, this part, which is kind of dark over that, I've kind of blocked it out. Let me undo that.
If you highlight the code, you should be able to change the font size at the top.
Let's see. Good idea. Thank you. Okay, so there's the part that I've highlighted there. Well, if I had gotten it all, is the part that goes below the line. So the first thing that we write down is we write. So you'll notice though that this thing is kind of outside and then this thing is paired together. So that means this rule looks like env turnstile, and now the command is seq, and then we've got an S1 and then an S2 and then a store. And that's going to go somewhere. Now, okay, so far so good, right? This line defining here is the bottom. Now, why does environment go outside? Because the kind of the convention of the rules is that if what is the type of this darn little thing? Okay. What is the type of, I'm going to go to shell and say, what's the :T big step STM? And you'll see it takes an environment first, and that's the thing that goes to the left of the turnstile for us. And statement and store. Now, what does he do in the book? Oh, where's my copy? I just had it in my hand. Here it is. He would say, because, we've packaged up the environment, and so this is, 4780 rules. And then there is the Huttel rule. And the Huttel rule has on the bottom ENVV, comma, ENVP turnstile. And all right, he uses these angled brackets.
Can you scroll down?
Excuse me? Oh, sorry. Yeah, that's a funny thing when I'm working on this, because I'm writing down here, but if I scroll here, it doesn't affect the screen view. These are like two separate processes looking at the same file. So thanks for, telling me. I wonder if I can zoom out a little bit so I get a bigger page. I don't see a zoom. Okay.
Just hold Control and use your mouse wheel.
Control and what?
Use your mouse wheel. Like the middle wheel on your mouse. If you hold Control and scroll in and out.
It's not working. It doesn't seem to be working.
Okay.
This is on Ubuntu, so who knows? Yeah. I know quite a few of you use this OneNote. So this really is no different, because our ENV is, well, it's right over here in the code, is this. Now, I have wondered if I had changed this to like, ENVV, let's say, and ENVP, which is what he calls them, if that would have helped. You think?
That makes a little more sense.
Yeah, a little bit.
Okay. All right. Well, I think it's pretty limited where I do that. So I could just try changing var to ENVV. Oh, I definitely don't want to do it there. I want to do it there. I want to do it not there. There. Not 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 there. I think there's going to be no other spot, because I'm pretty good about trying to use my abstractions, kind of like religiously. Once I write down something like this function lookup store, like this bang operator is, you know, a map operator, although I've overloaded it to be something a little bit different, to be a little bit more safe. And this is, I think, maybe these lookup functions for in the environment and the store are the only place that that is used at all. Bang is used again here and here. So there's only 3 places where that bang, which is potentially unsafe operation, is used. So anyway, his rule looks like this and our rule looks like that. And oh, I got to go change the other one as long as I'm doing this. I don't think there's going to be any more down below, but maybe I'll just look a little further. Nope. Shouldn't be. Okay. Let's see if it compiles. Maybe I broke it. Okay, well, I didn't break it, and I renamed those things. So maybe that makes it a little bit clearer that, you know, this other thing is just a record. Our version is just a record of those 2 things together. And so we could grab that code and put it in the node here. Where does it go? It's after the store, isn't it? I don't know, the mouse, it's just one little line or a few little lines. Where was that text size thing? This is really slow. I'm going too slow. I'm sorry. I should break these notes before
You need to click
class.
on home.
Home. Aha. Thank you. Yeah, there we go. Okay. So for some reason that doesn't actually match up. I guess maybe because I need to try to move this out, make this bigger. Okay, and somehow that thing got away. Okay, so now, one thing in the code that I've wanted to do, which I haven't done yet, is to, when I declare a procedure, I want to kind of like make it consistent. Like up here, and where is it, in declaration? Come on, where's my declaration thing? Maybe it'll help if I make this bigger. It's one thing. So here's a declaration, and the order of the things in the declaration for procedure is the proc name. Okay, that's the thing that we map. And then the call type, and then the former parameter, and then the statement. And I've got them like flipped around here for some reason. So this is a maybe confusing piece of code here, but I'm not going to change that right now. That's just a boring thing to watch. Okay, so there's our two maps. And I don't know, can anyone explain this bit of code, env0?
Is that like the base case kind of? Or like the null?
Yeah, it's like the null environment. It's an empty initial environment. And how do I build one? Well, there's two maps in that record. And this empty is, well, I don't know how those ones got in there, is the empty that's in the map environment. Like if I split this over here, you know, a really good thing that I think people who are having trouble with Haskell don't do enough is like, what is the type of this thing? And so what is the type of empty after I've loaded this? Whoops. If you can spell, it works better. Empty. It says, oh, that's a map. So you know that this empty is the map. It could be that, you know, empty is the empty list in some other context. But here at the top of the code, we imported data.map. And the strict part means that it actually is related to what we're doing. It basically says it's going to do call by value to evaluate the keys. So if your key loops forever, the map, you know, and even if you don't actually use the key, but you're trying to insert it into a map in some way, but that code never really gets completely evaluated or something, it's going to be strict. It's going to do call by value on the key, which makes, for some reason in the internal data structure they're using, makes these maps work more quickly. Okay, so I better start going a little faster. How do we get back to this role here? Okay, so here's the code. And we've got that below the line. And now we have this up. So I don't know, you know, how he would write this rule is like this, and it's okay. I mean, whenever you see, if you're writing a rule for big step STM and you see calls, other calls to big step, then probably they should go above the line. So this one is calculating S1, and I'm sorry, store prime using statement 1 in the current store at the time that you see the semicolon. And so what do? We go up above the line and we're going to write this one. We're going to write this one down first, and then we're going to write that one down second. And so what do? We say env, we don't change it, and we evaluate S1. And what store do we use? The same store. And we know that that's going to produce some kind of store prime. And then what do we do for this other next one is, so I don't need to highlight that anymore. So now to do this one, we write it over here. We got to say env turnstile S2, comma, and now we got to use the store prime. And there must be a way to. And that will evaluate to store double prime. And so then this one evaluates to store double prime. So his rule would be the same, except that he just has to write the ENVs out separately. It's ENVV, comma, ENVP, turnstile. Okay, so this is S1, comma, S semicolon S2. Oh, no, right. So in his code, he would actually in the rule, I should really do it this way, right? I should write S1 semicolon S2, but it's the same thing as that's seek S1 S2. And so here I probably should write S1 semicolon S2 because this is the syntactic, this is the syntactic form of this, and his rules go from the syntax. And so down here, it's exactly the same. So it's semicolon S2, STO, arrow, STO, and he would swap this around and do this. Right? To make it cleaner, like it looks like store is going to store prime, but before that, we have to evaluate S1 and the store that we had before, and we get STO double prime, and then we have ENVV, comma, ENVP, turnstile, S2, comma, STO double prime goes to STO prime. So, God, how come I can't? Well, okay, maybe I can just make this wider. That will give me a better view. Okay, there we go. So those are the rules that this code represents. And one thing is that the semicolon in the statements actually has a constructor in the data type. Oh, I should write that down. I should put the statement data type up here. Let's see, where is that? I think I'll put the statement in here. Okay. So this is now. He treats semicolons as second-class citizens in the declaration language. All right, so first of all, I guess I should stop and ask anybody, does anyone have any question on how this thing got translated?
One quick question is, so this stored double prime, is that coming from the big step environment of S2 in store prime?
Right. This one just evaluates to a store. I mean, if I wanted to make this code like a little bit more consistent with what he does, I'm not sure now I'm running into that 4780 thing. I could say down here, right, if you want to make the code very close to the rule, you should do this. Oops. And then this just becomes STO prime. So that should be lowercase. And then you just say this is equal to STO prime. So this could really maybe be a better way to write the code so that it really matches, you know, the way that you read the rules. There is a really interesting system in that there's some guys at the University of Illinois. Oh God, how can I get that back up? Let's see. Who have created a system where you write down your code as, I should have just done this. All right. Back. Where you write down your programming language, you define your programming language using these kind of structured operational semantics, and then they'll generate a compiler for you. So it's kind of like a programming, like you know, we have like, if you took compilers instead of principles of programming languages, you'd learn a lot about, well, it's Bison now. It used to be called Yak, but it's a compiler, they called it. And it generated like the compiler from an annotated grammar for the language. And this is a similar kind of thing, except now it's working from here. And then but the nice thing is that then you're all set to prove things in a nice way. So I don't know, does that make it clear how this should, you know, how the rule relates to this? Because now you can sort of, the where clause makes you read it backwards. I mean, evaluate this, and so the arrow goes to STO double prime. And then this, oh, now this should be double prime in here. If I'm going to do, I switched them around, but I didn't. How do I get in there now? Come on.
You're in the draw function.
I'm like a baby.
No, go back to draw.
Go back to draw.
Hit type instead of eraser.
Thank you. That's a double prime. Yeah. Okay, so I will erase this here, although that is the seek in the code. Right? That is C, and in the rule, he writes the syntactic version. All right, if everyone got that, let me go on and look and see if I can do something like a little, conceptually, it's like a bit more complicated. So what if we wanted to make semicolon, you know, how, so what is the syntax? First of all, let's look at what is the syntax of declarations. And the new syntax that I've put in here is looks like this. And so I have some new syntax for declarations. And I'm going to go to that, paste, home 14. It's going to blow out of the box. Maybe, oh, I got to select it anyway. Okay, resize the box. That's good. So now in this one, all right, we got our proc and we have our var like we had before. But his old syntax, the semicolon was kind of like not really an operator. It was just a syntactic sugar on top of, does he actually do it as a list? I did it as a list. No, he does it as like, he uses, let's see, let me go back and look. What did he do to declarations in this language? Statements. He implicitly makes it a list. Okay, so in, you know, huddle, he has the, I mean, he does, I'm looking at the rule. There should be like a syntax somewhere. I thought there was. That explains the whole thing, or is it only given in by the rule? All right, it's only given by the rules, I guess. So he has var rule and a proc rule, and okay, here we go. He has essentially, first of all, he has something called DV, which is a syntactic class of var declarations, followed by a DV or epsilon. And then he has a DP, which is the proc P X is S semicolon DV or DP, or it's epsilon. So now this is the syntax, and then there is in the begin statement, he writes down begin, and then he says, okay, DV, DP, S, end. Now, this first of all means variables are declared before procedures. And you can't ever declare a variable after. They only occur there like that. Now, what's the syntax that 4780, modified for this lecture, really, and this new code that that we're looking at is that we have something called declarations, and they're either a var x : equals a or proc p.
Scroll down again.
Oh, sorry. Oh God, yeah. So in the statement language, his thing goes dv dps. And so all variables are declared for procedures. You couldn't put another, I guess you could introduce another, but the thing is that there's no empty statement. So you could do another begin end block in there, I guess, but anyway, whatever. His language works like this. Now, it's possible to have a begin end block here with no declarations because they both could be epsilon. And notice, if they're both epsilon, there's no semicolon. You just write down S. You say begin, and then you write down your S. If there's only a var declaration, though, you're going to end up writing x : equals a semicolon. Then this is epsilon, which doesn't get displayed. So you'd get a var equals a, var x equals a, semicolon, and then your statement. So it works out kind of nicely that if there is a declaration, it ends with a semicolon. And if there is no declaration, you get no semicolon, and you just write down the statement. Okay, and in this language that I'm looking at, that I'm proposing, which is quite a bit, which is different because this one gives semicolon status to an operator in the declaration. So proc p x is s is the next thing. And then after that, we have, oh no, what's this damn thing? After this, we have D1 semicolon D2 or epsilon. And so now this thing here is this D semi operator up here. And D empty, maybe I should have called it D epsilon. So if we want to do this, it changes the rules. Now, this changes the rules for the declaration rules. And it changes them as follows. So let's look at the code over here and see what the code says they are. So big step declaration. Okay. So now, one thing is I should point out, and this is like a type thing in his language, is that his language for DV here, you know, his rules look like this. Well, I should say, you know, like, I don't know, what do I want to say? I want to say like, well, okay, I'll just write down some of the rules. He has, he separates out the environment that he doesn't need and the other environment he carries. So for the var rule, he says, okay, we might, actually, I don't even know if you don't need it at all, does he? The var rule's the same as it previously was. So he's back on another page. I don't want to write down the wrong thing because I want to be precise here. Okay, yeah. His var rule has no turnstiles in it because it just has, it's got the var x equals a semicolon dv, more variable declarations, and then he has the envv in the store, and that returns an envv and a store. Because now why does he need these two things? Well, because declaring a variable does two things. It changes the store by extending it by 1 and adding a new location for the new variable x. And then it sets that value to a. And so then the other thing that it does is, in his rule, is he has to evaluate dv up here. So he's got to say, okay, evaluate dv in envv, and except that you have to propagate this information into the environments used up here. So what is envv? Well, first he says, look, env comma sto shows that a evaluates to v. Okay. And then, you know, he's got this business of L is equal to ENVV next. So that's the next location available. And ENVV, oh, this is a double prime. It's equal to, take the environment at the time the variable declaration was seen. So that's ENVV, and update it so that X points to L, which is the new next store location. And then he has to update next to point to new L. And so let me scroll over so you can see what I'm writing. So I'm right here. It goes to new L. And remember, new L is just equal to, well, in our code, if we wrote out, for example, our thing, the L is a loc, so it's loc, you know, so loc k is equal to loc k plus 1. So next now points to the next location. So he's managing all this memory management in his role. And now, what do we have to do? What else do we have to do? There's one more thing, right? We got to update the store. The store has to be updated so that L, the new location, points to the value V, which is what you get back from evaluating A. And so now then, those three things evaluate to ENVV prime, comma, STO prime. And that's what he returns down below. Is ENVV prime and STO prime. Ah, darn. I wanted to work backwards from my rule for the semicolon, though, to show you something different. So, I mean, it seems like, though, what I've written here, so now you're going to have to figure out what these union operators are. But, well, let's look at the var rule first. I think we have time to write that down and from the code. So if you look at this code up here, what do? We say, okay, we're working from var x colon equals a comma env. So first of all, we don't have this stuff, this extra stuff, sto. And what does that evaluate to? That evaluates to this. And so this is env0. So now when you evaluate a variable, you don't build in the environment, a variable declaration. You don't build in the entire environment. You just make an environment that knows that X points to A. And then you leave it up to the semicolon operator to actually put those things together using this union operator. So this one just goes to, so you let, you know, first of all, you got to do your big step V. So this, whoops, this line here is identical to what he does in his rule, where he does env comma store turnstile AV. So we can write that down in our new rule. So we do that. And what is that doing? That's just evaluating the expression A. So we can say, STO, I'm sorry, ENV, comma, STO, turnstile, A, arrow V. So now we got that. So that looks the same. And then we say, okay, call alloc of store to get back of L is a new loc and STO double prime is what we get back from allocating, calling alloc on the store that we have here, STO. And then we say, okay, STO prime is equal to, and if we wrote it like this, like he does, we'd say, oh, that's STO double prime, where L points at V. And then we would say up here, it is ENV0, which is the empty environment, updated so that X points to L. And then you use STO prime. And that's the rule. There's no rule above it. And if we had more time today, I'd say, let's go over the semicolon rule. So you know what I'm going to do for the sake of the you're free, it's perfectly reasonable for you to sign off now. Class is over, but I think I will just, as long as I'm recording and I've got this set up, I'm going to just continue to explain the semicolon rule now. So if you know, officially class is over. If you got something else you got to do, sign off. It'll be in the recording. Maybe first I should ask, are there any questions though about what I've been doing so far? Kind of the big picture is that it seems strange to me that in his statement language, he gives kind of a semantic weight to semicolons. And then in the declaration language, they're just kind of meaningless little bits of syntax. And there is a way to make, so, you know, they're just meaningless. The semicolon just separates this from something that could be empty, the DV from something that could be empty. And it works out nicely, kind of syntactically, that but the semicolon is just syntactic sugar. So why not make the semicolon just syntactic sugar in statements? Well, that would be like a good exercise. Go back and figure out how to change the statement language so that the semicolon is invisible by doing something like every statement is by default. He's saying here, every variable declaration by default is some kind of list. It's possibly empty, or it's a cons of var xa onto a DV list. So this is like, you know, I was just reading a paper the other day and he said, morally, this construct here is a list. You know, morally, this thing here, oops, I gotta draw. Morally, this thing here is a list. And this thing here is a list because this is equivalent to con semicolon, but, and if you could have the empty list, but why didn't he do that with statements? He could have. He didn't do it with statements because it's well understood that the semicolon really is a kind of a semantic operator for composing together statements. But why skip it in the declarations? That I'm not sure about. And we can make it so that it works in the declarations. So anyway, all right, I'll see you next week, but I am just going to continue talking for, I don't know, 5 or 10 minutes to try to get the dsemi thing, that turned back into a rule. And the code is pretty clear. If I grab this code, I mean, this code is pretty good for, can I go over here? Yeah. Paste it in. Go to home and resize it. Okay. So I don't know, for some reason they wrapped that around. Let's see. Okay, there we go. So how does it look? How does the rule for this look? If I can find my magic pen. It is that, maybe I'll make this black. I'm getting tired of this orange. Okay, is that D1 semicolon D2 comma ENV comma STO evaluates to ENV2, and I'm going to say dot union B, or maybe I'll say plus union, because this is a little bit different from ordinary union in that when you look things up in this, what is this thing going to be? An environment is a record containing a pair of maps. And so what's going to happen is ENV2 is going to be the prominent environment, the environment which, if I had an entry in ENV1 and ENV2 that was the same, the one from ENV2 would be the one that would shadow the other one, and so that would be the one you find. And in the same way, you'd find whatever's in ENV before ENV1 before you'd find ENV. We'll look at that operator in a minute, but I can just write this down now as ENV2 plus union ENV1 plus union ENV, where the meaning of D1 in ENV comma STO is the pair ENV2 comma STO prime. Oh, right. This thing down here has to be like, and I'll call it like, all right. I mean, I'm using 1s and 2s here because I did in the code, I guess. Oh, not for stores. That's interesting. Okay. So we can look, I'm not looking at the code. I'm just writing it down because I know what it is. But if we look at the code, it tells us what exactly it is. It's D1 ENV STO maps to ENV1 STO double prime. And then D2 comma, now I have to use ENV 1. Uh-oh. Where's the ENV1 coming from? I can't see my code. I got to scroll back over it. So I evaluate, oh, this should be ENV1 here. Just read the code, man. D1 evaluates the ENV1 and STO double prime, and D2 evaluates in ENV1. And I'm feeling like this may be an error. It could be that this needs to be ENV1 plus ENV comma STO double prime. And that evaluates to ENV2 STO prime. Okay, so I think that's a new rule for semicolon. And so this one becomes all those union together, and then I get STO prime as the final. So there's the rule. Now, why am I saying I think I got this wrong? This bit of code works on all the examples that we have, but I think that it could be that this would cause an error because suppose that D2 was a proc declaration that depended on D1, which was a variable declaration, then the environment that we put in here for D2 wouldn't be correct. We wanted to include everything that we've seen up until the point where we've declared this. That's all built into ENV. So when we do ENV1, we have access to all that stuff. And now what we want to do is we want to make it so that when we do this D2, we want to have access also to the stuff that was just done in ENV1 plus the stuff that was done in ENV. But we only return the stuff that was done here, and then we glue it all together down here using the union operator. Now, I guess we could glue it together up here and then only have one union down here, but I think maybe that this maybe reads better. So anyway, all right. Oh, there's still a few people around. I didn't see you. So does that make sense? Now, well, maybe it doesn't until we see the union operator. We can look at the union operator. So in the code, it's union ENV. So I got to go up and look at union ENV. And where to go? It's with the environment. Okay, this is, I don't know, maybe this is written in a slightly unclear way, but union ENV says app ENV union and union. And what app ENV does, it takes two operators on maps and then two maps, ENV1 and ENV2. So these are both records. I'm sorry, not two maps, two environments. So these are both records containing two. And so what do? You go down inside here and using, Haskell's record notation, you look up ENVV and ENV2, and then because this union operator, if you look here, if I check the type of union, it takes two maps and returns a new map. And if you look it up in Hackage, it makes it clear that the entries in the first map take precedence over the entries in the second map. And that's actually what we want. Like if there's a previous entry for X, but now we're redeclaring a variable X in a local block, we want the new X to be the one that's important. And so, this one should shadow, this thing actually allows for, you could say like, this is dumb, but you could say, var X gets the value of 7, semicolon, var X gets the value of 8. So that's a sensible declaration in this, because you could redeclare a variable. Now, in some languages that would, and we could add the semantics easily that says first thing you do when you see a variable declaration is look up in the map and see if the variable has already been declared. And if it has, this is not sensible. But that's kind of like mixing your type checking with your semantics. We're kind of operating currently in an untyped language because we haven't done any type checking. So anyway, this means for the variable part, use the map function union to glue them together. And for the proc part, use union. I guess when I wrote this, I imagined that, you might only want to do something to the proc part and nothing, and you could use this app env to write down, like, I don't know, forget the second one completely. Forget the first one completely. You could write different ops in here. But union env is what I'm writing here as, so in the code. So I don't know if does anyone have a question if you're still hanging around? Okay.
This makes sense.
So I don't know. It's kind of a side thing. It's like a refinement on what he's doing, but it does seem odd to me to do the semantics for semicolon in the statement language and then kind of like make it a nothing in the declaration language when there is when it really kind of is a composition operator. But to make it work as a composition operator, we have to do this other funny thing, which is, whoops, that should have a like a little ending thing on it. But the rule is like this: there's nothing else to do when you're evaluating. And then the meaning of this is an environment that knows that X points at location L and store prime is one where L is equal to V. I mean, maybe this would even be better if I did it like this. I say like, okay, get rid of the, I didn't mean to do that. I did something down below. Let's see. We could get rid of that, and then we could say STO where L goes to V. And then we can get rid of this down here. So then the side things that we did were, obviously, we have to evaluate what the meaning of A is to know what this value should be stored. And I should modify, I could modify allocate so that you gave it the value down here. I could modify it so that you gave, V down here. Right now, it allocates a store and sets it to 0. But then you immediately, in every var action, var declaration, you then reset it to something else, like here. So if I did that, then this just would be, STO double prime, because allocate would have taken care of, if this is like an initial value. that might only make case for variable declaration. It makes sense for variable declarations. So anyway, that's how you could add semantics for semicolon instead of kind of, you know, just making them kind of hidden operators that built into this semantics for var, and a hidden operator built into the semantics for proc. You know, the semantics for proc would look very much like this, with the DP being a rule line above. And all he's doing is a list. This is, you know, simulating a list of proc declarations. This is simulating a list of var declarations. And the nice thing also in this other way is that you can do vars and procs and proc, you know, you could do var, proc, proc, var, proc. You could declare in any order. So anyway, all right. Well, thanks for those of you who stuck around. Any other questions? All right. I'll see you later next week, or no, Thursday. Today's only Tuesday. Yeah. Okay. Thanks for coming. See ya.
Thank you.